Good morning students. In the second part of the video, we will discuss properties of operations on integer. So, let us start. We have the properties closure property, commutative property, associative property, distributive property, additive inverse and identity. So, first of all, let us discuss closure property. So, if a and b are the two integers, then their sum is also an integer. So, here we have example. As you see, 14 plus 30. 14 is an integer and 30 is also an integer. So when we add, its answer is 44. So 44 is also an integer. So when we add two integers, its answer is also integer. Next is 14 plus minus 5. So as you see, 14 and minus 5 both are integers. So when we add, its answer is 9. So again we get an integer. So remember that in closure property, if a and b are the two integers, then their answer will always be an integer. So integers are closed under addition. Okay. So next is commutative property. This property states that changing the order of the addendums does not affect the sum. Means, in this property, let us take an example. As you see, 6 and 4. When we add 6 and 4, its answer is always 10. Okay? And if we add 4 and 6, again its answer is 10. So what will we observe? We observe that in both the cases the answer remain same. So we observe that if a plus b is always equal to b plus a. Okay, so this property states that changing the order of the addendums does not affect the sum. Whether you can write b here or here, answer remain same in the both cases. So addition of integers is commutative. Okay, next we have one more example. Minus 6 plus 4. When we add, its answer is minus 2. And 4 plus minus 6, its answer is again minus 2. So in the both cases, answer remains same. So addition of integers is commutative. Next is associative property. This property states that changing the grouping of numbers being added thus does not change its value. For example, we have 6 plus 2 plus 1, which is equal to 6 plus 2 plus 1. So first of all, we can add 6 plus 2. So when we add 6 plus 2, its answer is 8. Next is plus 1. So 8 plus 1, 9. Now, in this case, firstly we add 2 plus 1. 6 plus 2 plus 1, answer is 3. So 6 plus 3, answer is 9. So what will you observe? In the both the cases, the answer remain same. So whether you can add firstly two numbers or you can add last two numbers, in the both cases answer remain same. So this is known as the associative property. Okay, so next we have one more example. 6 plus minus 2 plus 3. So first of all, we can add these two numbers. When we add, its answer is 4 plus 3, its answer is 7. Okay, now we solve this. Firstly we add these two. Minus 2 plus 3, its answer is 1. So 6 plus 1, answer is 7. So what will we observe? We will observe that in the both cases answer remain same. So while adding integers, when the grouping is changed, the result does not change. So this property is called associative property of addition. Next is distributive property. This property states that when two numbers have been added or subtracted and then multiplied by a factor, the result will be same when each number is multiplied the factor and the product are then added or subtracted. So what does it means? Like we have one example. Here is minus 2 into 4 plus 3. So firstly add them. 4 plus 3, its answer is 7. Minus 2 into 7, answer is minus 14. Now solve this side. Firstly we multiply minus 2 into 4, answer is minus 8. Plus minus 2 into 3, answer is minus 6. Now minus 8 in plus minus 6, what is its answer? Its answer is minus 14. So what will we observe? We observe that when we add two numbers and then multiply a factor, the result will be same when each number is multiplied by the factor and the products are then added. Okay. Next is identity property for addition. This property states that the sum of any numbers and 0 is the number itself. Okay, so we have an example. 5 plus 0, we add 0 to number 5, so its answer is 5. And when we add 0 to minus 4, its answer is again minus 4. So always remember that the sum of any number and 0, the answer remain the number itself. So adding 0 to any integer does not change the value or identity of the integer. So a plus 0 is equal to a. Next is inverse property for addition. So this property states that the sum of any number and its additive inverse is 0. So like minus 6 plus 6, when we add, its answer is 0, and 10 plus minus 10, its answer is 0. So remember that for every integer there exists another integer such that its sum is 0, which is the additive identity. Okay, so as you see the example, in this example minus 6 is called the opposite or additive inverse of 6. Okay, and similarly 6 is called the opposite or additive inverse of minus 6. So remember that there exists another integer for every integer a, that is minus a, such that if we add them, its answer is 0. Okay, which is the additive identity. So minus a is called the opposite or additive inverse of a, and vice versa. Next we have some properties of subtraction. Let us discuss the first property of subtraction, that is closure property. So when we subtract two integers, we will get an integer. Let us take an example. So minus 5 and 2. As we see that minus 5 and 2 both are integers. So we subtract these two integers, the answer is minus 7. So as you see, 7 minus 7 is also an integer. So always remember that when we subtract two integers, we will always get an integer. So integers are closed under subtraction. The next property is commutative property. So in subtraction, commutative property is not true. Okay, while subtracting two integers, the order of subtraction alters the result. For example, 6 minus 3. As you see, 6 and minus 3 both are integers. When we subtract the integer, answer is 9. Okay, and minus 3 minus 6, when we subtract these two integers, answer is minus sign. So what will you observe? You will observe that both the answers are not same. So a minus b is not equal to b minus a. So subtraction is not commutative for integers. Next is associative property. So in associative property, first of all we will discuss an example. So firstly here, subtract 8 and 3. When we subtract 3 from 8, answer is 5. Minus 2, so 5 minus 2, answer is 3. Okay, now firstly subtract 3 and 2. When we subtract 2 from 3, its answer is 1. So 8 minus 1, answer is 7. So what will you observe? You will observe that in both the cases answers are different. So what it means? It means subtraction is not associative. So in subtraction, a change in order changes the answer. So integers are not associative under addition. So a minus b minus c is not equal to a minus b minus c. Clear? Next is property of 0 for subtraction. When we subtract 0 from any integer, we get the same number. For example, 3 minus 0, its answer is 3. Minus 3 minus 0, its answer is again minus 3. So what will you observe? In the both cases, when we subtract 0, we get the same answer. Okay, so a minus 0 is equal to a. So always remember that property of 0 is when 0 is subtracted from an integer, we get the same integer. Next, we have an example. We subtract 0 from 7, its answer remains 7. Next is we have some properties of multiplication. First property is closure property. So let us take an example, minus 3 multiplied by minus 2. When we multiply these two integers, answer is 6. That is again an integer. So if a and b are the two integers, then a into b is also an integer. So this is called closure property of multiplication of integers. That when we multiply two integers, its answer is also an integer. Next is property 2. Firstly, let us take an example. 8 multiplied by minus 4. When we multiply 8 into minus 4, its answer is minus 32. And when we multiply minus 4 into 8, its answer is again minus 32. So if a and b are any two integers, then a into b is equal to b into a. So this is called the commutative property of multiplication of integers, that grouping in multiplication does not matter. So multiplication is associative for integers. Next, property number third. So let us take an example. First of all, multiply minus 10 and 9. When we multiply minus 10 with 9, answer is minus 90. Now multiply minus 90 with minus 8, we get 720. Okay. Now firstly we multiply minus 8 and minus 10, then we multiply the answer with 9. So when we multiply minus 8 by 10 minus 10, its answer is 80. And now multiply 80 by 9, its answer is 720. So what will you observe in the both cases? You will observe that in the both cases answer remain same. It means we can say that the grouping in multiplication does not matter. Whether you can multiply first two numbers, then multiply the answer with the third number, or firstly you can multiply second and third number, and the answer that we get, we can multiply that answer with first number. In the both cases answer remain same. So if A, B and C are the three integers, then A into B into C is always equal to A into B into C. So associative property of multiplication of integers hold true. Next is property 4. As you see, here is an example. Multiply 1 with minus 5. So when we multiply 1 by minus 5, what will we get? We get the same answer, that is minus 5. So if any integer A is multiplied by 1, the product is the same integer A. That is A into 1 is equal to 1 into A is always equal to A. So integers do not lose their identity on being multiplied by 1. So 1 is called the multiplicative identity of integers. Next is property 5. When we multiply minus 4 by 0, its answer is 0. So when an integer is multiplied by 0, the product is always 0. If A is any integer, then A into 0 is equal to 0 into A is equal to 0. Next is property number 6. When an integer is multiplied by minus 1, we get the additive inverse of that integer. For example, 5 into minus 1, its answer is minus 5. So, which is the additive inverse of 5? So, if A is any integer, then A multiplied by minus 1 is equal to minus 1 multiplied by A is equal to minus A, where minus A is the additive inverse of A. Next is property 7, that is distributive property over addition. So here we have two methods to solve this question, that is minus 5 into 6 plus minus 3. We can solve this question in two ways. First one is, firstly add these two numbers, 6 plus minus 3. Its answer is 3. Now add 3 with minus 5. Its answer is minus 15. The second way to solve this question, Firstly, we can multiply minus 5 with 6. Its answer is minus 30. Now multiply minus 5 into minus 3. Its answer is 15. Now add minus 30 and 15. Its answer is minus 15. So what will you observe? We observe by solving this question in the two different ways, the answer remain same. So if a, b and c are any three integers, then a into b plus c is always equal to a into b plus a into c. This is called the distributive property of multiplication of integers over addition. Next, we have some properties of division of integer. So first one is closure property. So division is closed for any integer. For example, if we divide the first integer by the second integer, we get again our answer an integer. But in some cases this property does not hold true. For example, let us take an example, 8 divided by 9. So as you see that 8 is an integer and 9 is also an integer. When we divide, its answer is 8 by 9. So as you see, 8 by 9 is not an integer. So always remember that integers are not always closed under division. So one more example, as you see, 25 divided by 5. When we divide 25 by 5, its answer is minus 5. So 25 and 5 both are integers. When we divide, its answer is minus 5. That is also an integer. But in this case, 8 by 9 is not an integer. So integers are not closed under division. Next is commutative property. In case of subtraction, the order in which division is carried out is important. A change in the order results in a change in the answer. For example, when we divide minus 12 by 1, its answer is minus 12. And when we divide minus 4 by 1, its answer is minus 4. So, as you see, when you divide minus 12 by 1, its answer is minus 12. And when we divide 1 by minus 12, its answer is minus 1 by 12. So, in both the cases, what will you observe? That both the answers are not same. So, if a and b are the two integers, then a divided by b is not equal to b divided by a. So always remember that integers do not possess the commutative property for division. Next is associative property. So order is important in division. Always remember that associative property does not apply to the division of the integers. So in division of integers, the result changes when grouping is changed. So this property does not hold true for division. Let us take an example. 64 divided by 8 divided by 2. So firstly divide 64 by 8. Its answer is 8. Now divide it by 2. Its answer is 4. Now 64 divided by 8 divided by 2. So firstly divide 8 by 2. Its answer is 4. Now divide 64 by 4. Its answer is 16. So what will you observe? You will observe in the both cases the answers does not same. So always remember that the result changes when the grouping is changed in division. So a divided by b divided by C is not equal to A divided by B divided by C. Next is we have some another properties of division by 1. So if we divide a number by 1, the quotient is the number itself. For example, we divide 7542 by 1. Its answer remains same, 7542. So when an integer is divided by 1, it always gives the same integer. So A divided by 1 is always equal to A. Next is division by itself. If we divide a number by the number itself, the quotient is 1. For example, if we divide 275 by 275, its answer is 1. So A divided by A is always equal to 1. Next is division any number by 0. So division of any number by 0 is meaningless. If we divide any number by 0, it is meaningless. So here we have 35 divided by 0, which is equal to no meaning. So it is a meaningless. Okay. So next is division of 0 by any number property. So 0 divided by a number gives 0 as a quotient. So when we divide 0 by any integer, its answer is always 0. For example, 0 divided by 7, again its answer is 0. So if A is any integer other than 0, then zero divided by A answer remains 0. So thank you.